Assalamualaikum and good day everyone. My name is Ain Athirah and I will be presenting the first part of our project, which is the project overview, system development methodology and project charter. Our project is titled Pharmacare Pharmacy Management System. The purpose of this system is to improve the efficiency of daily pharmacy operation by integrating important pharmacy function into one centralized system. This system supports several main modules including prescription processing, medication dispensing, inventory management, supply management and electronic patient record. By integrating this function, the proposed system helps reduce medication error, improve inventory control and enable pharmacy staff to manage information more efficiently. For this project, our scope selected the waterfall model as the system development methodology. We choose the waterfall model because the requirements provided in the case study are already clear and well defined. Therefore, a sequential development approach is more suitable for this project. As shown in the diagram, the waterfall model consists of 6 phases. The first phase is planning, where we identify the project objective, scope, schedule, and overall project requirements. Next is analysis, where we analyze the functional requirements of the pharmacy management system based on the given case study. After that is the design phase, where we prepare the system design using diagrams such as contact diagram, data flow diagram, enhanced entity relationship diagram, EERD, as well as the input and output design. The fourth is implementation, which represent the development of the proposed system based on the completed design. Next is testing, where the system is tested to ensure all functions operate correctly and meet user requirements. Finally is maintenance phase, focus on correcting errors, improving system performance and updating the system whenever necessary. Overall, the waterfall model provides a systematic and well-organized approach, making it suitable for developing the pharmacare pharmacy management system. Next, I will explain the project charter. The project title is Pharmacare Pharmacy Management System and the project is developed using waterfall model. The main objective of this project is to improve pharmacy operation by providing a centralized system for managing prescription, medication dispensing, inventory, suppliers, and patient records. The project scope including several core functions such as prescription processing, inventory management, supplier management, medication report, and electronic patient record. The key stakeholders involved are the pharmacy manager, pharmacist, pharmacy staff, patient, and supplier, as each of them interact with different part of the system. Finally, the project deliverable include the system development methodology, project charter, work breakdown structure, Gantt chart, contact diagram, data flow diagram, EERD, input design, output design, and the final project report. That's all from my presentation. I will now hand over the presentation to the next presenter to continue with the work breakdown structure and Gantt chart. Thank you.
Hi, students. My name is Nur Ain Syahirah, and today I would like to present the work breakdown structure for Pharmacare Pharmacy Management System project. In this project, have 5 major phases. Phase 1 for the project planning, forming the team, choosing our methodology, and building this plan. Phase 2 requirement analysis, studying the Pharmacare case study and producing the context diagram, DFD level 0 and DFD level 1. For phase 3, this is system design, the ERD plus our input-output samples. Phase 4, documentation, drafting, compiling, and quality checking the report. And phase 5, presentation and submission, which is what are you working right now. Each phase is then broken into work pages. The important point is that every single work package has one name owner. Nothing in this project is left so somebody will do it. That is how we kept 5 people moving without duplicating the work. For the Gantt chart Pharmacare Pharmacy Management System project, we map those work packages onto a timeline. Our project runs 8 weeks, from 18 May through to the submission deadline on 12 July 2026. The diamonds are our 5 milestones. Milestone 1, our project plan approved on 24 May. Milestone 2, all analysis diagram completed on 9 June. Milestone 3, system design completed on 20 June. Milestone 4, the final draft ready on 5 July. And milestone 5 is the submission on 12 July. The two decisions are worth highlighting. First, the analysis tasks run in sequence, not in parallel. The context diagram fits DFD level 0, which is fits DFD level 1. We deliberately did not let those overlap because if the diagrams are built at the same time by different people, they stop being consistent with each other. Second, wherever the work did not depend on each other, we overlap it. You can see the design and documentation bar running side by side so that 5 people are productive at the same time instead of waiting in a queue. We also built a 1 week buffer before the deadline so that a late diagram does not put the whole submission at risk. This is our plan. Now let us look what we actually analysis over to next member.
Hi, my name is Nurul Umairah. I will explain about context diagram. As we know, a context diagram represents the highest level of system abstraction. It clearly defines our system boundaries, its overall scope, and how it interacts with the surrounding external environment. In this diagram, the entire pharmacare application is modeled as a single central system process, labeled process 0.0 pharmacare pharmacy management system. Our system interacts directly with three main external entities: the patient, the pharmacist, and the supplier. Let's trace the data stream running between them. First, looking at the patient entity. The patient entities, the system cycle by submitting their prescription details and patient information. Once the system processes this request, it delivers the prepared medication and labels back to the patient. Second, let's examine the pharmacist entity. The pharmacist relies on the system to retrieve critical patient record access and allergy alerts to ensure dispensing safety. The system also generates comprehensive medication-related report for them. In turn, the pharmacist feedback, counseling documentation, and medication adherence details into the system. Finally, looking at the supplier entity at the bottom, the system monitors inventory and automatically dispatches replenishment orders when items are running low. In response, the supplier provides medication shipment and pricing terms. Next, let's move to the data flow diagram level 0. Let's go through the process sequentially. Process 0.1 is prescription processing and medication dispensing. This handles the front and operational loop. When the patient submits prescription details and patient information, this process reads the patient medical history and allergies from data store D2 patient record store. Simultaneously, it queries data store D1 inventory database to verify stock levels and expired dates. Once verified, it passes the update inventory quantities back to D1, issues a prescription verification notification to the pharmacist, and dispenses the prepared medication and labels to the patient. Next is process 2.0, inventory management and supplier relationship. This manage back-end supply chains. It constantly streams stock level data from data store D1. If a shortage is detected, it sends reorder alerts and inventory report to the pharmacist. Pharmacists can make inventory adjustment and contract review directly into this process. Process 2.0 also interact with the supplier by sending replenishment orders and receiving medication shipment and pricing terms. Active term and save as supplier record inside data store D3 contract database, and inventory arrival are updated as update stock in D1. Finally, process 3.0, electronic patient record and patient care, handles medical charting and compliance. It receives new prescription data from process 0.1 and archives them as update records into data store D2. It provides the pharmacist with real-time patient record access and allergy alert and medication-related reports, while capturing the pharmacist's counseling documentation and medication adherence logs.
Assalamualaikum, my name is Nur Ain Syahirah. I will be presenting data flow diagram or the FD level 1 for the Pua Khe Pharmacy Management System. This diagram shows the detailed workflow of how a prescription is processed before the medication is dispensed. Unlike the FD level 0, which only presents the main process, the FD level 1 breaks down into smaller sub-processes so we can clearly understand how data flow through the system. The process begins when the system receives the patient prescription and stores the patient information in the patient record database. This is important because the system needs complete and accurate patient information before any medication can be processed. Having accurate record also ensures that the following process are carried out correctly. Next, the system verifies the prescription by checking the patient medical history and allergy record. The purpose of this step is to ensure that the prescribed medication is safe and suitable for the patient. By checking this information first, the system helps prevent medication error and reduce the risk of allergic reaction. After that, the system checks the inventory database to confirm that the requested medication is available. Instead of assuming the medicine is in stock, the system verifies its availability first. This helps avoid delays and ensure that the pharmacist can prepare the correct medication without any interruption. Finally, once the prescription has been verified and the medication is available, the pharmacist prepares the medication, generates the medication label with the correct dosage instruction and dispense it to the patient. As a result, the patient receive the correct medication safely and efficiently. Overall, this workflow ensures that every prescription is processed accurately, safely and efficiently from the moment it is received until the medication is dispensed to the patient.
Hi, my name is Fatin Najiha. I will present the Enhanced Entity Relationship Diagram section. In the Pua Khe system, we have designed 8 main entities which have divided into 3 important modules. The first one is patient and prescription module. Patient profile and allergy record are stored in the patient entity. This entity has one-to-many relationship with the prescription, as a patient can receive many prescriptions through their treatment. The second one is medication and dispensing module. To avoid duplicates of medication data, the bridge entity prescription detail is used to store specific medication quantities and dose. Meanwhile, the dispensing entity record the medication delivery date and counseling notes confirmed by a pharmacy. The last one is stock and supplier module. The medication entity tracks the current medication quantity remaining. When the stock is low, the system will generate a new order under the inventory order entity to the selected supplier, where the detail of each medicine item order will be recorded in the order detail. Overall, the structured database design guarantees data integrity and prevent any loss of operation information in the pharmacy.
Next, I will explain the input design of the Pua Khe Pharmacy Management System. This prescription form is designed to help pharmacists enter information quickly and accurately. The prescription ID is generated automatically to prevent duplicate record. The pharmacist then enter patient details, select medication from a drop-down menu, and record the dosage, quantity, allergy information, doctor name, and prescription date. Using a drop-down menu reduce typing error and improve data accuracy. The form also includes save, clear, and cancel button, making it easy to manage prescription record. Overall, this user-friendly design improves efficiency, reduce error, and help accurate patient record.
Next, we go to the output design. We have produced 3 main types of output. The first output is medication label. This is physical output in the form of the print slip that will be posted on the patient medical container. This label displays important information such as patient name, prescription ID, medical expired date, and clear dosing instruction in bilingual to ensure that the patient takes the medication correctly and safely. Second output is low stock and reorder alert. This is script output for internal use by pharmacy staff. The system will automatically display a color code, warning code when the quantity of medication is below the minimum level. This output greatly helps pharmacy to make decisions about purchasing new stock from preferred supplier with just one click on the generate purchase order button. The third output is electronic patient medication history report. This final output is a comprehensive report that generates a patient medication history, allergy information such as penicillin, and notes on the past medication consultation. This report is important to help medication office make more accurate clinical decisions for patients safely. In conclusion, this user-friendly and informative output design ensures that the pharmacare system can provide safe, efficient and high-quality pharmacy service. That's all. Thank you.